Hello and welcome to another tutorial. In this tutorial we will be making a third-person character controller which we can later alter to whatever game we want to make. Our main goal is to make him a universal character controller, that we have a separate script on how we communicate with our character. So if we want to use this controller to move enemies, we can, or if we want to move our player directly by hitting WASD, or later use a pathfinding solution like the Navmesh agent to move him, we can do just that by simply changing the way we use him. So for instance here I'm moving the character by hitting WASD. Okay, so the way we have it here, whenever I hit W, the character is moving towards the forward of the camera. So if I hit S, he's moving the other direction. If I hit A, he's moving towards the left of the camera, T towards the other side. So you see here, if I change my camera orientation and hit play again, I will hit W again and he's probably going the other direction. He's stuck there, so let's take him from there. Not you. Let's unpause. So you see he's moving towards where the camera is looking. Okay, the other functionality this character controller will have is move a player with the Navmesh. So if you hit play, you see the character is following our waypoint. So another good thing our controller will have is that it's going to be easy to change models. So as you see here, I have this on a separate script, and beneath it I have my model. So if I want to change models, I just simply disable the one, enable the other model I want to use. Let's change my camera back where it was, and if I hit play, let's maximize this. Now I'm controlling a different model without having to worry about moving scripts from one model to the other. Okay, so let's start. So yeah, I'm using animations and the models from the sample assets. You can download either here from the asset store, or you can find the links below with this project. I've cleaned it up because the sample assets have lots of other stuff we don't really want to use here. So either way it's fine. The same animations and things there are in the stealth project, so we don't really care about those stuff. And the next thing, our controller is based from the one in the sample assets, but it's way more simpler, so that it can suit our needs, and we can make changes in our controller script depending on what our needs are. Okay, our main goal is to have a universal character movement which we can take as a base on every project we want to start, and we can tweak stuff depending on what we want to do, what the game is about. Okay, I will start this as a part of a series which will be on the next videos. So for consistency sake, we have to start from here. We will start creating our animator controller first. So if you know how to set up an animator controller and you know how to make blend trees like this, you will find a timestamp in the links or in the video that will move forward, and you can go straight to coding. Now in the links below you will find inside the example files, you will find a controller already made, so you can use that if you don't want to watch this part. But it's a good habit to know how blend trees work. Okay, this will help you a lot in the future. So anyway, let's start. So let's start to create our controller. Open up the scenes folder and open up the example scene. This is the scene we will be working on. Now in order to start, let's go game object, create empty. Let's bring it into view. Let's rename it. And we will need a capsule collider. Let's make it bigger. A rigid body. And an animator. So let's freeze our rotation to X and Z, so our character won't fall to the left or to the right. We want him to move only on, to rotate only on the Y direction. Now for this, now we need an animator. So create, right click, create animator controller. Let's name this and drop it in an animator. Open up the animator, right click and form a new blend tree. Let's rename this. Double click. Now we will need two floats. One is if we're moving forward, and one is for our where we will turn. We will use this when we want to turn. Now add some motion fields to start with. Add 4 for the beginning. We will change our blend type to DD freeform Cartesian, and we will change our parameters to turn and forward. So the first one, it's going to be the idle. So let's go to sample assets. Inside our characters folder, there is the third person character folder, and we have our animations. Open up the idle and drop the idle in our field here. So for the idle, we want to be the position of 0 and the position of y to be also at 0. So when there is no movement here, the floats are at 0 value, we are at the idle. Okay, so the next one we want is to turn when we want him to, when he is standing. So go to stand turn and drop stand quarter right, stand quarter turn right. Now we want him to turn when he's at 0.5, when the x, the turn, this one, is at 0.5, and there is no movement in our forward float, and for some reason it has stuck, so it's a bug for Unity, I guess. So the next thing we want to add is to turn the 45 degrees. So drop the stand half turn right, and we want him to do that when our turn float is at 1. So that is for the right. Now let's add to the left. We will take the quarter turn left and drop it, and we want to turn to the left when he's at negative 0.5 and there is no movement to our forward axis. Add the new motion field, add stand half turn left, and we want him to turn 45 degrees to the right when he's at negative 1. Reset the position y, and now if you see here, if we see our preview window, when we move this, when we start giving a value, it blends to the desired directions. Okay, so now let's move. Now we want him to walk. Add a new motion field. We want him to walk forward, so in order to do that, we will add the turn direction to be at 0 and our forward float to be at 0.5. Drop the walk animation. Now we want him to quickly turn to the side, to the right, and in order to do that, we want him to have, when he has the turn float is at 1 and the forward float is at 0.5, we will add the walk turn sharp, walk right sharp. Alright, now we will add another one. This one is going to be 0.5 and our forward will also be 0.5. The 0.5 is when we want him to walk and not run. If we put this to 1, he we will later put the animation for running. Now you might notice that this is 1 and this is 0.5. It doesn't really matter. We can change the position. It doesn't change anything. So let's drop our animation here and let's add a new for the left. So negative 0.5 and 0.5. Let's drop our walk left. Let's add a new one, 0.1 and 0.5. Let's drop our walk left sharp here, and if we hit play now he's turning because the turn float is at negative 1. If we zero this and start the forward, we can see him start working. And now we have a nice effect here where we blend to each state. So with this one we don't need transitional animations from one state to the other. Okay, so let's stop that and let's add our running animations. Add a new motion field. We want this to be at 0 and we want this to be at 1 when we want to run straight forward. Close this so they are not in the way. Drop a run animation and add two new motion fields. Now we want this to be at 1 and at 1, and this is going when we will drop our animation where we want him to turn to the right to make a sharp turn to the right. And below that we're gonna drop the turn to the right, but not quickly. How you call it? As you see here, nope, the other direction. He's running, he's making sharp turns to the right, and if this is at 0.5, he will turn to the right, but not so quickly. Let's add 2 more. And drop run left sharp and a run left. Now this is going to be negative 1 and the forward will be at 1. The left will be negative 0.5 and the forward will be at 1. And now we have our controller. As you can see here, we can change the values and he will play the desired animation and blend between each all. Okay, so now that we have our controller, we have already dropped it. Okay, so let's close that, this, and we will start writing our script. We call this character movement. Open up our script. New script. Let's start by adding our helper variables. First we're gonna need a float that will help us multiply our speed. We'll give it a value of 1. Next we will add a float that is a stationary turn speed, and we will give you a value of 180. Next we want our moving turn speed, and we give it a value of 360. Next we will add a variable, bool, that will help us determine if we are on the ground, our animator. Now we will need a vector 3 for a move input, a float that is our turn amount, another float that is our forward amount, and a vector 3 that is our velocity on our three-dimensional velocity. Okay, so this is our move vector. This is the calculated amount to pass to mechanim, and this is the calculated forward amount to pass to mechanim. Okay, so we will need another float which will be a jump power. We're not gonna have jump here, but we will later need them, so it's good to have it from here. Now the next one we will need is an eye comparer, and it will help us compare array cast later. So this is algebra variables. Now we will need another function here which will help us set up our animator. And the first thing we want to do is get our animator. Okay, now we want to search for every animator that is in our child game objects, and we want to do that because we will be using this animator where we want the avatar mask to be taken from underneath our character. So let's go back to our script, and the way we do that is by using a for each loop, and we will say for each animator, child animator, in get components in children, and the component we want is animator, if child animator it's not the same as animator, this animator, our animator, our mask, our avatar mask for our animator is the same as our child animator avatar. So after we take the avatar mask, we destroy our child animator, and we break our for each loop because we want the first animator we will find, and that is because we might have more animations, more animators. Let's say he is a robot and he has more animations on his face or on his back. We only want to take the first animator we find, and that's because we break for each loop. Now let's drop our start. Let's drop our function in our start. And now let's start with our other functions we will need. The next one is on animator move. And this updates the movement of the character based on its current speed and the move speed multiplier. So if we are on the ground and time dot delta time is higher than 0, now we add the time dot delta time because we want him to check in the next frame, not the first frame we hit to move, the second. And now we will need a vector3 there, which equals our animator delta position multiplied by our move speed multiplier and subdivided with time dot delta time. So now with this we calculate the speed that the character should have by the delta position. It's the position, the difference in the position between one frame and the other, between the current frame and the previous one. And our speed is the position difference of the animator multiplied by the speed multiplier subdivided by time. Okay, this is how you find the speed in the real world. Now we want our y to be untouched. We don't want to make any changes there, and we want to change our velocity, our rigid body velocity, to our new vector. Okay, so the next thing we will need is array hit comparer. Now this is going to be a class and not, let's delete the update for now. So this is a class and it's array hit comparer, and it's an eye comparer. Okay, so this compares two objects and we want him to return raycast hit distance compared to raycast hit y dot distance. Might be some errors here, and the error is here. So this compares to raycast and brings the shorter one. Now that we have our ray heat comparer, we will add a function that is going to work as our ground check. Now let's add it here. We will add void ground check, and we will create an array from the origin of the character transform sin plus a 0.1 on the y-axis and our direction to the negative y-axis. And in order to do that, we write array transform dot position plus vector3 dot up multiplied by 0.1 and negative our up direction. Okay, so this is the origin of the array, and this is where we want him to go. And there is one error. And the error is, oh yeah, we didn't add our constructor in the beginning. So let's go down. We will need an array for array casts, and we will do array cast all we will add array, and the 0.5 will be and our distance we want to be for half a point. Now we will need array heat comparer, and we'll add our constructor, and now we will add now we call this function, this system function, because we want to sort the hits on our comparer based on the distance. Okay, so we will start our if statement here, and we will say if the character is not airborne due to a jump. We will talk about jumps in our next tutorials, because we want this to be a universal controller, character controller. And if we want to add jump, we can always come back later and make some changes. But in our case, we don't need this, but we will add it just in case. So if the character is not airborne due to a jump, we assume that we are on the air and falling. So we enable the gravity to our rigid body, and for each hit in our hits, we will check if we haven't hit a collider that is a trigger. We want our character to stick to the surface. This helps us if our character is moving down the slope, so it will help him stick to the ground. And in order to do that, we want to check for our velocity, the y of our velocity. If it's smaller or equals to 0, then our rigid body position will be equal our vector3 dot move towards rigid body position heat dot point time dot delta time multiplied by 5 and this. So we are changing the rigid body position to be at the hit point. Okay, and we do it over time delta time. Okay, so in addition to that, we want him to be on the ground. That will be true, and we disable the gravity on our rigid body, and then we don't want to take any more hits, so we add the brake, so we ignore them. Now you can add a new check. So if we want to, because we enable the on ground here, if you want to disable this, which we will later on a later video, we will add different animations when we are airborne. So we will add above this an on ground false, but for now we will leave it commented out. Okay, so that is our ground check function. And now let's move on to convert our move input. A new function. And this function will help us convert the world relative move input vector into a local relative turn amount and forward amount, which we are required to head in the desired direction. So let's start. We need a vector3, and we'll add a local move, which will equals our transform inverse transform direction move input, and we want to calculate our turn amount. So in order to find our turn amount, we use a math function attenuation 2. This is we calculate our turn amount trigonometrically. Okay, so this is pure math. Now we have our convert move input. Now that we have our convert move input, we want to pass these values to our animator. So we'll add a new one, a new function. We call it update animator, and in here we will add and the apply root motion, we will turn it to true. Later on we will change this to be affected by script. So if we are on the air, we don't want apply root motion, but we'll add this here just in case. So we will set our floats, and our forward float in the animator will be our forward amount. We'll add the speed down time, and we want it to be by time.delta time, and our turn float will be our turn amount with 0.1 downtime and time.delta time. So we will need another one function to help him turn faster, and this will be called apply extra turn rotation. This will help the character turn faster. This is in addition to the root motion of the animation, and it's based on our moving turn speed and stationary turn speed and the forward amount of the character. So we will need a float turn speed, which will add a mathf linear interpolation between a stationary turn speed, our moving turn speed, and our forward amount. And we will rotate our transform by 0, and our turn amount multiplied by our turn speed by time.delta time at 0. Okay, so transform.rotate rotates our character. We don't want him to rotate at the X, we don't want him to rotate at the Z, and we rotate him at the Y, our turn amount multiplied by our turn speed by time.delta time. Okay, so now that we have all our helper functions, we will go up to the beginning, and we now want a public function that's gonna be our move function. Now this move function, we will access this function from other scripts, from our user interface, and basically it's what connects us with this script. So in order to connect this, we will need a vector3, and we will say all the vector3 move we will get, we want him to be always normalized, so that we're not messing with high values, because we multiply a lot. And we want our move input to be our move, the move input in here to be this move. Okay, we want our velocity to be a rigid body velocity, and we start calling our functions. We start with a convert move input, we will apply the extra turn rotation, we will add the ground check and update animator. We have completed our character movement scripts. We will need another one that is gonna be our user input. So let's create a new one. Let's call this user input. Open it up. Okay, so let's start with our variables. Delete this for now. The first thing we're gonna do is a public bool if you want him to work by default. Let's make it false for now, and now we're gonna need a private character movement. It's gonna be character move. We're gonna need another private transform cam, which will be our camera. A vector3, it's going to be the forward of our camera, and our private vector3, which is gonna be our movement. Now we will add the start function. And we will say if camera dot main it's not null, so if there is a camera in the scene, our camera will be, our camera transform will be camera dot main dot transfer. Okay, and our character movement our character move will be get component character movement. And now on fixed update, we need a float with a horizontal axis. Okay, we have done this before. Float that is gonna be our vertical axis. And we will say if a camera it's not null, our cam transform it's not null, our camera forward will be our scaled vector3 of the cam dot forward, and new vector3 1 0 1, and all this will be normalized. And our move equals the vertical multiplied by our camera forward plus our horizontal multiplied the cam dot right. So with this, if we hit W or the forward input, we will always be working towards where the camera is looking. Okay, we will see this later. And now we will add an else function. We might not want a camera, so if there is not a camera in the scene, we will take the word the global forward and the global right. Okay, and this will be a vector3 dot forward plus horizontal multiplied by vector3 dot right. This is just in case there is not a camera in the scene. Now we want to normalize our movement. This doesn't record. Normalize. And we want to add a boolean that if we want to walk or run. So if this will be input get key code dot left shift. You can add this as a button, but let's do this here this way, so we don't have to add the new input. So now we want a float that is going to be our walk multiplier. We'll give it a value of 1, and we will say if we walk by default and we have hit our walk toggle, our walk multiplier equals 1. Else our walk multiplier equals 0.5, and we will add, if we are not walking by default and we hit our walk toggle, our walk multiplier equals 0.5, and the walk toggle is off, our walk multiplier equals at 1. Remember, in our animator we set 1 we will run and 0.5 we will walk. Okay, and after that we multiply our move with our walk multiplier, and we call our function our move function in our character movement script, and we'll pass it the move float. And that's about it. So save this. We have a third person controller, and we will need a model. So go to sample assets, character, third person character, models, drop it right underneath it, make sure he's at 0, 0, 0. Okay, make sure his feet are on the ground. Let's drop our scripts, character movement, user input, and let's go closer, our game, let's make maximized, let's hit play. As you can see, now we have a character that moves. I'm hitting left, I'm hitting right, forward, backwards. Now if we change the orientation of the camera, you will see here, if I press forward, he walks towards where the camera looks. So later on we will make a script that we will move the camera beneath him, and you can make him walk wherever you want. This is like similar to Grand Theft Auto or other games. And that's about it in our third person character controller. Now the nice thing about this controller is if we close this and drop another model inside, make sure he's on the ground and hit play, as you can see we can change the model pretty easy. Okay, so in addition to that, if we now go and make a new script, let's call this AI character. Let's enable Ethan. Oh, doesn't take space as well, so open this up. Now that it's open, let's go start adding our variables. So we want this to have an agent. We want our character movement script. We want a target transform, so let's make it public here. This will act as a waypoint. And we want a float that is going to be our target change tolerance. So if the waypoint is closer to him, he won't have to change. Let's give it a value of 1. We will add another vector 3 that's going to be our target position. Okay, so our agent will be in our navmesh agent in our children game object, and our character move will be our character movement. And now in update we will write if our target is not null, and if our target dot position minus the target pos, the magnitude is higher than our target tolerance, our target pos, the stored target position, equals our target position. And we say to our agent that the destination we want to go is our target pos. So after that we want the position of our agent to be equals to our transform position, and we pass to our character movement script, to our move function, the desired velocity of our navmesh agent. Okay, so we will add an else here. So if it's still if our target is still it's not, if we don't have a target, we still need to pass values on our character move function, but we will just passing 0 values. Okay, so with this, if we save, we will add another game object beneath, which will act as our navmesh agent, and this will just have a navmesh agent. Okay, we will add a stopping distance to be greater than 0, and let's disable our user input and drop our AI character. We will add a new game object in the scene that's going to be our waypoint, drop it in the target transform. So now we need to bake a navmesh map. You see, I have already done this. In order to make this, so let's clear it. So we have to be careful. We want the level, or every obstacle of the level, to be at static. In particular, to be navigation static, if we want it to bake on the navmesh. So after we select it all and make it static, we go to navigation, which is window navigation, and go to bake, change the inputs here to what we want, and simply hit bake. Okay, so now we have our navmesh agent. You see now, let's change this to, let's give it so that we can see. Let's unmaximize this, it was unmaximized. And now if we hit play, we will see him go to the waypoint. So this is another use for our character controller. If we don't want to use, if we don't want a game that it's controlled directly by the user input, like a strategy game, or if we want to use this for our enemies, we can simply use the same script, but we only change how we communicate with the script. And the added value of this script is that if you see here, it's much more dynamic. So if I change this, now I can't, but let's say here, if I take this out, you see the navmesh doesn't change, we have to rebake it now. But if I hit play and take our waypoint and move it towards there, he will still be walking because he is moving. Now this of course is a pathfinding problem, but because our character is moved by physics and takes the navmesh agent as a guide, we don't have errors, and it's much more dynamic, so we can make more interesting things with this. In the other way you can use the navmesh, if he is always upon a navmesh, this here will probably give errors, or he wouldn't fall down. So we can do another thing here. Let's say we close this. Oh no, let's see it here. If we take this apart, and let's move him up there. Okay, so if he fall down, he just simply goes to the other navmesh. So you can do some cool things with this. Of course it has some problems, the character, but it's a good starting point. So if we want to add more things in our next videos, it's a good starting point to have. So it's best to back up this project, and when you start prototyping a new game, start from here. So that is our tutorial. We can even do this. So let's use let's delete this. Let's put our waypoint somewhere else. move our third-person controller somewhere there. Let's turn our camera so that we can see, and now we've hit play. You see, I control the robot and he's moving by the pathfinding. As you see here, he's jumping because we move the character with forces. He goes, no, the speed is higher than he's moving, and he looks like he's jumping in the air. Later on we can change that, or we can even give it a higher mass, or give him another physics material, and that didn't change. Anyway, so this is it. If you liked the video, don't forget to like, subscribe for more videos, and in the next videos we will get into actually creating a game. So stay tuned for more, and thanks for watching.